Alright, hello guys. I'm so sorry that I cannot make it to class today, but lesson as usual, because yeah, my grandmother was admitted to hospital yesterday night. I was in A&E for the whole night until like 6 o'clock, so I have to take a short break from school today. Yeah. So we will learn on this intersection between two circles. Let's turn our workbook to page 133. Right, so let's take our workbook and turn to page 133. Okay, right, on page 133. Now, we are looking at the intersection between two circle now. All right, so we are talking about the distance between the two particles, the distance between the diameter, the center point of the two circle that we have. So this A to B is the distance between the center of the circles. This is the distance, okay? And then we are also talking about the radius of the circle and the radius of another circle. So if you look at this diagram here, right, if the distance is greater than the two radius add up together, because these two radius you add up together, right, the distance is greater than that, it means that, right, the two circles are not intersecting with each other. They're not intersecting. Okay, right? Now, but also, right, if let's say the distance between the 2 points here, the distance, the D, here, right, AB lah, is less than, this is not more than, I typed wrongly, all right, is less than your R1 minus R2, right, then it will be not intersecting, right, but is inside. The circle is inside of another. The circle is inside of another circle. So there are two cases of not intersecting. One is that they are not intersecting, but they are outside of each other, or they are not intersecting, but they are inside of each other. One of it is inside of the another circle. Okay. So this is when the D, right, the distance is greater than 1 plus R1 plus R2. Then the other one is D is less than R1 minus R2. Now guys, which one is R1, which one is R2, it doesn't matter. Okay, which means that which one is the first radius or the second radius, it doesn't matter. But you must always remember, you have to keep this as positive. So you will take the larger one minus the smaller one. Okay, all right, that's the first thing. Or now you see, they are also touching each other if and only if the distance now, the distance here, the distance is equals to R1 plus R2. If the two radius add up together, right, is equals to the distance, then they are touching each other because it's just exactly the same. Okay, so that's why this is touching. But if let's say the distance here is equivalent to R1 minus R2, then they are also touching each other, but is inside of another. Okay, all right. Then the next one, okay, this one, right, okay, I find that this idea here is not good enough, all right, to give us a good conclusion. So intersecting circle means that the two circles are intersecting each other. So in order for the two circle to prove that the two circle intersect each other, I need to show that the R1 minus R2 is the distance, right, is in between of these two values. R1 minus R2 less than D, right, is in between of R1 minus R2 and R1 plus R2. Okay, so this one, right, you have to memorize. If you don't memorize this one, right, there's no way you can do the question already. Okay, so you need to memorize all these 5 concepts that we have, whether they are inside, outside, or whatsoever, or which one is it. Okay, they are not given in exam, so you have to memorize, you have no choice. All right, and so far, right, we have not seen any IG question asking about this yet because it's a new chapter, and we have no sample question how it's going to be asked, but we only based on the textbook and using the textbook to predict. okay, what is possible. Okay, all right. So I'm going to teach you how to use this idea here. Now let's look at example number 1. The question, right, want to show that the circles touch the circle, both circles touch each other. They touches. So when they touches, right, means that I need to show that D, right, is equals to R1 plus R2, or D, right, is equals to R1 minus R2. Either one of this. Okay? So let's find out that this equation, let's say this one I call as the first equation, the x squared plus y squared minus 10x minus 6y plus 30 equals 0. Now, from here, right, what is the center? Let me call it C1. The center is negative 10, take out, it becomes positive 10, then you divide by 2, so it's 5, comma. Negative 6, you take out, it becomes 6, divide by 2, so it becomes 3. Remember this? We have learned this before, right? And then the radius is equals to square root of 5 square plus 3 square minus 30. Okay, 1 minus 30 because of the plus 30 sign here. Alright, so here, right, you will get square root of 25 plus 9 minus 30. So you have square root of 4. So this is 2 lah. This is R1. Okay? Okay, right. This one we learned before from the previous part. Okay? Now the other one that we have is for this circle now. This x squared plus y squared, this one. From here, right, I can see that my C2, my center here, because it's plus 6, so it becomes negative 3, comma, minus 6, so it becomes 3. Okay? And your radius 2 is equal to square root of negative 3 square plus 3 square minus 18. So this is going to give you square root of 9 plus 9 plus 18. So it's 36. Okay, which is going to give you 6. Okay, all right. So we need to find the distance. So let's find the distance between the center. So the distance is equals to square root of 5 minus 3 square plus with 3 minus 3 square. The distance between the C1 and C2. Okay, so from here, right, I get square root of 8 square. So it's just square root of 8 square here because it's 0. Then it's just 8 lah, the distance. Okay, then you have to find R1 plus R2, so which is equals to 2 plus 6, which is equals to 8. Then the other one is you also can take R2 minus R1. It doesn't matter, I told you. You just need to take the big one minus the small one. So 6 minus 2, which is equals to 4. Okay? So because of that, you can see that since D, right, is equals to R1 plus R2. Okay? Therefore, since that is so, right, the circles, okay, intersect each other. No, they're going to touch each other at one point. Okay, and because R1 plus R2, my D equals to R1 plus R2 is this case, you know, is this case number 1. So they are actually outside of one another. Okay, so that's why I can say that, okay, and the circles, okay, are outside of one another. Okay, can? Alright. Okay, I just want to show you how it works, what's the idea look like. Let me try to type into Desmos to show you. Right, so if you look at Desmos graph here now, Desmos here says that it's loading. Okay, you have x square plus y square. Okay, then you have now what is it? Minus 10x minus 6y. So minus 10x minus 10x minus 6y. Okay, then plus 30 equals 0. Okay, the first circle. Then the second circle is x squared plus y squared plus 6y plus 6x minus 6y. So x squared plus y squared plus 6x minus 6y. Correct on. And what is it? And no, minus 18. So minus 18 equals 0. You see the circle? They actually touch each other and they are outside. So this is what they want to show. Okay, can? So this is what we are trying to show lah. Okay, all right. Now, next one, the next question, can write, okay, because we have shown one of it. Yeah, that's one. Okay, let's do it. So what is it? They say determine the number of intersection between the circles with the equation x squared plus y squared equals to 2. This one, x squared plus y squared equals to 2. Right, now what is the center here? The center here is C1, right? The center here is what? Nothing, man. There's no x and y, man, right? It's 0, 0. And the radius 1 is equals to square root of 2, guys. Now, how do I look at this? Remember that we have two ways of looking at equation for circle. One is this form, which is the expanded form. The other one is the original form, which is x minus a square plus y minus b square equals to r square. So the r square now is equals to 2. So r is equals to square root of 2. Okay, all right. So the next one, right, you have this one. You have this x minus 4 square plus y square equals to 10. All right. Then your C2 will be what? What is your C2? What is the C2? C2 is what? It's 4, 0, and your R2 is equals to square root of 10. Okay, because it's the same idea, the formula there. Right? So what is your distance here? Your distance is square root of 0 minus 4 square plus 0 minus 0 square. So which is equals to square root of 16, which is equals to 4. Okay? Okay, so then right, you can also see that we are using the R1 minus R2 as usual. So we can check R1 plus R2 is equals to square root of 2 plus square root of 10, which is equals to square root of 2 plus square root of 10, which is going to give me 4.576. And if you find R2 minus R1 lah, in this case, is square root of 10 minus square root of 2, which is equals to square root of 10 minus square root of 2, I get 1.748. like that lah, correct not? Okay, so now you can see, right, the distance, the d, the distance is in between of these two values. Do you see that? That the distance, right, is 4, is actually in between of 4.576, which is your R1 plus R2, and also 1.748, which is your R2 minus R1. Alright? So because of that, we are looking at this idea here now. The distance is in between of R1 plus R1 minus R2 and R1 plus R2. So that's why they are intersecting each other at 2 points. Okay, so answer, say you write down that since 1.748 is in between of 4 is in between of these two values, okay, which is R2 minus R1 is in between, the d, right, is in between of R2 minus R1 and R1 plus R2. So the circles, okay, intersect each other at 2 points. Okay, that's what it means. All right. Okay, now next one, let's look at question C. It says that, right, find the range of values of k such that the circle of this circle, all right, and this circle intersect at 2 distinct points. That's the question, what the question want. Okay, so is the first one, what is the C1? Let's look at this one first. I'm looking at this one first, the yellow one. Okay, so I use yellow colored one. I use red. So what's the C1? So in this case is the expanded form. The C1 will be -8 become +8. So divide by 2, so it's 4. Then -12 become +12, divide by 2, so it's 6. Then your R1 is equals to square root of 4 square plus 6 square minus, okay, this 12 you bring over is minus 12 so minus 12. Okay, so from here I get square root of 16 plus 36 minus plus 12. I get 64, which is equals to 8. Okay, then C2, which is the second one. C2 is this one. C2 is the second equation. So C2, you will look into, it's also the expanded form. So we can see C2 is actually equals to +4, become -4, divide by 2, so it's -2. Then -28 divided by 2 is +14. Right? And your R2 is equals to square root of -2 square plus 14 square, okay, minus k. Because like I said, this minus k to bring over. So 4 plus 14 square is 200. So it's square root of 200 plus k. Okay, all right. So then let's look at it. They say that there are 2 distinct points. So your d, right, which is you need to find the d's first. What's the d here? So d is square root of 4 minus 2, so +2 square, plus with y minus y, so 6 minus 14 square. So your d is square root of 6 square plus -8 square. So it's 10. The distance is 10. Okay, so because they say is the distinct 2 distinct values, so we know that d, right, is in between of R2 minus R1 and R1 plus R2. Doesn't matter, like I said, right, as long as positive you do. So R2 minus R1 is just square root of 100. Yeah, sorry, square root of 200. Okay, plus K less than 10. Less than R1 plus R2 is, oh sorry, I forgot plus 8. Minus 8. Plus K minus 8. Less than 10. Less than R1 plus R2 is square root of 200 plus K plus 8. Okay, so we need to solve for both sides. So from here, we do the left side first. So it's square root of 200 plus K minus 8 less than 10. So this one is, the other one is 10 less than square root of 200 plus K plus 8. So then you move lor. So square root of 200 plus K is less than 18. Then 200 plus K is less than 18 square is 324. Then K, right, is less than 124. The other one, you move this 8 over. So 10 minus 8 is 2. Less than square root of 200 plus K. Then you bring over. So it's 4 less than 200 plus K. So K is more than negative 196. Correct or not? Okay. So since that, you see, if I draw the number line, right? This number line, negative 196 and 124 is like that. 196 is more than, yeah, you don't include that, it's more than, and 124, right, is less than. So if one that more than, one less than, you see the overlapping part is here. Therefore, right, your K value is in between of negative 196 and 124 because there is an overlapping part. Okay, get it? Right, I hope you get it, the idea. Right, that's why, right, the 5 rules up here you must memorize. It's actually not difficult to memorize. One is D is more than R1 plus R2. One is D, right, less than R1 minus R2. Then the other one is equal because they're touching should equal, right? So D equals to R1 plus R2 and D equals to R1 minus R2, and the other one is just in between of the two, the minus and the plus R only. Okay, now let's do a question. Try exercise 6, right? Okay, now exercise 6, right? I want you to consider the radii and also the distance between the centers to determine whether they are touching each other, intersecting each other, or do not intersect. I also need you to tell me, right, whether, okay, they are inside or outside of each other. Inside or outside. Okay, right? Now, the first one is the general equation. Not, you must remember there are two methods, guys. Okay, if let's say, right, we have the expanded form like this one, y squared, then let's say minus 8x plus 6y, then minus 10 equals 0. Then this one, right, the C1 will be, you take negative 8 out and divide by 2, so it becomes 4. Then plus 6 you bring out, become negative 6, then plus divided by 2 is negative 3. Then your radius, you have to count square root of 4 square plus negative 3 square minus 10. That's when they give you expanded form, you will do like that. Okay, but if the question gives us the general form, let's say it's negative x minus 4 square, then plus with y minus 3 square equals to, let's say, 16, alright? Then your C, right, will just be the number only, right? Don't need to expand, don't waste time and expand them. So it will be just 4, 3, and R2 is going to be 4 only. Okay, why 4? Because this 16, right, is r squared equals to 16. So r equals to 4. So there are only two types, either A or B only. Okay, all right. So the first one, right, is which one? Which one do you think it is? It's the second one, the actual form of the circle formula. Okay, so what is a C1? 0, 0 lah, right? No number ma. And your R1 is equals to 5. Okay, then the second one, the C2 is negative 3, 0, right? And your R2 is equals to square root of 4, right? Which is equals to 2 lah, in that your R2. So that's why your distance, right, is equals to square root of 0 minus 3. So it's 0 plus 3 square plus with 0 minus 0 square. So this is just 3 lah, the distance, if you calculate. Then your R1 plus R2 is equals to 5 plus 2, which equals to 7. Then your R1 minus R2 equals to 5 minus 2, which is equals to 3. Right? And you can see that since that, right, you can say D, right, is equals to R1 plus minus R2, which is 3 equals to 3 lah, right? So the circle touch each other at one point, okay, because it's minus and one circle is inside, right, inside of another, because minus is inside, plus is actually outside, so it's minus. We are talking about this one and this one with this one, so therefore it's inside. Okay, can? Right. Okay, maybe I show you another one more question. Okay, let's say question 2 lah. Okay. Now let's do question 2. It's also the original circle formula. So this is x squared plus y minus 3 square equals to 5. So the C1 is 0 and 3, and your R1 is square root of 5 only, because it's the general formula. This one. Okay, so that's why this 5, right, is the R square. Okay, now the next one is the second one. Your C2 is 6 and 1. X is 6, y is 1. Then your R2 is equals to square root of 8, because the 8 number here. Okay, so as usual, we will find the D first. So D is equivalent to square root of 0 minus 6 square plus with 3 minus 1 square. So which is going to give you 36 plus 4, which is equal to square root of 40, which is equivalent to square root of 40 is 6.325 lah. Okay, then your R1 plus R2 is equals to square root of 5 plus square root of 8, which is equals to square root of 5 plus square root of 8 is 5.06. Then you have R2 minus R1, which is equals to square root of 8 minus square root of 5, which is equals to square root of 8 minus square root of 5, which gonna give us 0.597 2, 4, something like that. Okay, so which one is it now? Let's look. This D, right, okay, is more than R1 plus R2, right on? So we are talking about the first case here. You see, D, right, is more than R1 plus R2. So D is more than R1 plus R2. Is it correct or not? D is more than R1 plus R2. Correct? So because of that, right, we know that since D, right, is more than R1 plus R2, so the circle do not intersect each other, right? The circles do not intersect each other. Okay? And because it's plus, so it's outside, inside, outside. Okay? And the circles are outside of one another. Outside of one another. Okay? So what you're going to do is that for today, right, you just do question 3 onwards until question 8. Alright, is it question 8? Alright, you just try first. Then when I come back from tomorrow, I will discuss the question. Okay? Alright, that's all lah.